Welcome to the Bentley Systems training course, where you will learn how to design concrete structures using the Reinforced Concrete Designer within Staad Pro. In this first video, we are going to be learning how to prepare the model for design. This includes reviewing our slab orientation, generating your load combinations, analyzing the structural model, and creating your physical members and slab objects. In this training course, we will be designing the concrete beams, concrete columns, and concrete slab for a model that's already been created in Staad Pro. The majority of the modeling steps have already been taken care of, such as assigning properties and plate thicknesses to all of the elements in the model. We've already assigned all of our appropriate specifications, supports, and loads for this particular model as well. What we're planning to do is to design these members in the Reinforced Concrete Designer, and there's a couple of key areas that we want to pay attention to when preparing our model for design. The first thing we're going to take a look at is the slab orientation for this particular area. So I'm going to create a new view window of this area, and on my keyboard I'm going to hold down Shift T. This will bring on the local plate axis system for each of the plate elements. Now what you probably noticed is that the default local Z axis for each slab element is currently pointing downwards. It's important to note that for Staad Pro, the side of the plate from which the positive local Z axis points is considered to be the top of the plate. If we were to design the concrete slab according to the current slab orientation, the stress at the top surface or the top layer of reinforcement would be recording the stresses and reinforcement at the physical bottom of the plate because that local Z axis is pointing down. To ensure that we were able to easily interpret the slab analysis and design results, we will adjust the local Z axis of the slab elements to point up instead. To do that, we're going to use our geometric constants commands. So if I go up to my commands menu, I'm going to select geometric constants and I'm going to select the plate reference point command. Now this particular slab happens to be drawn at an elevation of y equals 11 feet, and that's according to the global axis system. So what I want to do is I want to point the local Z axis towards the reference point, and I want a value for y to be greater than the level of this slab. So let's go ahead and set this at 20 feet. I'm going to assign it to view, which means it'll find all of the slab elements in the model and point their local Z axis towards this elevation. Once I'm done, I can click OK. Staad Pro, if you notice, is redrawing all the plate elements to now have a local Z axis pointing up. This will make it considerably easier to interpret our results later on. Once we are done, we can close our individual window and again hold down Shift T to turn off our local axis orientation. The next step in our workflow for preparing our model for design is to generate our design load combinations. In the page control area, we're now going to select the General tab followed by the Load and Definition subtab. Now if I expand the load case detail section, you're going to notice that several primary load cases have already been defined for this particular model, which includes dead load, live load, and seismic load. We now need to generate our design load combinations for our concrete members and slab elements. To generate your load combinations, you're going to highlight your load case details and click the Add button. In Staad Pro, you have two main methods of generating load combinations. You can manually define your load combinations, and you would do that through your Define Combinations option, or you can use the program to automatically generate load combinations for you, which is what we're going to do for this course. We're going to go ahead and select our code for combination, and we're designing concrete elements, so we'll select the ACI code, and we're going to select table number 1. Before we generate loads, we're going to draw our attention down to the bottom of this dialog, where we have a checkbox to create repeat load cases. Now in Staad Pro, we have two main types of load combinations. We have a traditional load combination, which is a load combination which produces a set of results which are combined algebraically to produce a superimposed sets of results for post-processing. That's what would happen with this checkbox unselected. Alternatively, you can also create repeat load cases. A repeat load is a primary load case that can be used to combine other primary load cases together. This is different than a load combination since it is able to obtain the results of more than one load case acting in tandem. If the analysis of your model involves any nonlinear situations, such as a p-delta analysis, you will have to specify the repeat load cases instead of load combinations to correctly capture those second-order effects. For this model, we are preparing to perform a p-delta analysis, so we'll make sure that Create Repeat Load Cases checkbox is selected. Once we've specified all our parameters, we're going to click our Generate Loads button, and then click our Add button to officially write these to the input file. Once we're done generating load combinations, we can go ahead and click Close. The next step in our workflow is to tell the program what type of analysis we are going to perform. For this training, we are going to be performing a p-delta analysis, which can incorporate the p large delta effects and the p small delta effects. Your p large delta are your second order effects induced on a structure due to the movements of its mass under lateral loads. In addition to that, your p small delta effects are your second order effects caused by displacement of the member between its bracing points. To invoke any analysis command, you will select your Analysis Print tab in your page control area, and then automatically your Analysis subtab should come up. In the Analysis Print Commands dialog, we have several different analysis types, including your Perform Analysis command, this is your linear elastic analysis, and your p-delta analysis command, which is what we'll select for this training. So the p-delta analysis command is automatically going to incorporate your p large delta effects, and then we also have a checkbox here to also incorporate your p small delta effects, which we will do for this training. Once we're done specifying all of our parameters, we will click our Add button followed by Close, and then you'll see that that p-delta analysis command is appearing at the end of the input file. You might also notice that the p-delta analysis command and the change command have been issued after each IBC seismic load case to instruct Staad Pro to analyze each load case individually and then to reset the stiffness matrix before analyzing the next load case. Now, since this particular model contains a multiple analysis command structure, and since it also includes repeat load combinations as primary load cases, we must also use an additional command called the setNL command. This will be required to allow Staad Pro to set aside some additional memory space for information to be added later. It's typically needed when you have a multiple analysis run and then additional load cases are added after an analysis has been performed. To invoke your setNL command, we're going to go up to your Commands menu, go to Miscellaneous, and then use the setNL command. What you want to do in this dialog is set the maximum number of loads to be either greater than or equal to the total number of load cases in your model. For this model, we'll set it equal to 50, and then we'll click OK. The next step in our workflow is to create our load envelopes. In your page control area, select the General tab followed by the Load and Definition sub-tab. In the Load and Definition dialog, we're going to find three main areas: your load definitions, your load case details, and your load envelopes. We're going to create a load envelope, which are basically groups of load cases set under a single moniker. In the RC Designer, load envelopes will be used for the design of concrete beams and concrete slabs. To create a new load envelope, we're going to highlight the Load Envelope section and then click the Add button. Now we could create load envelopes directly in the RC Designer, or while we're modeling our structure, we can create it in the modeling mode, which is what we'll do for this video. Now what we want to do is select all the load cases or combinations that we want to use in the design of our concrete beams and slabs from the Available section and move it over to the Selected section so it's included in this envelope. We're going to select all of our ACI design load combinations. So I'm going to select my first load case. I'm going to go down to the bottom of the list If I hold down the Control and Shift key, I'm going to select everything within that list, and then we're going to move it over to the selected area using the single right-hand arrow. So here I've selected all of my load combinations. Once I'm satisfied with this load envelope, we'll click the Add button, followed by Close. And for your particular model, you can create as many load envelopes as you need for the design of different elements or entities within your structure. Next, we're going to form our physical members in the modeling mode within Staad Pro. Staad Pro defines beam members as line elements connecting nodes. To correctly model the connection between the filler beams and the girders members must also be connected to the same nodes at the ends of the filler beams. As a result, the girders must be divided into separate members spanning between the ends of nodes of the filler beam. Staad Pro refers to these separate members that form the girder as analytical members. In the actual structure, however, the girders are single members spanning between columns and are referred to as physical members. Staad Pro provides for the grouping of the individual analytical members into physical members using a special member group called a P member or a physical member. The following conditions must exist for a physical member to be created. The analytical members must be interconnected and collinear. The local axes of the individual analytical members comprising the physical members must be identical, and the sizes of the individual members must be the same. Now, physical members can be created either in the Staad Pro modeling mode or directly in the RC Designer. For this exercise, we're going to create them in the modeling mode. And the reason for that is when you create your physical members in the modeling mode, it officially writes them to the input file, which allows for greater flexibility later on. To create a physical member, we're going to select all of the members in our model using the beams cursor, which is already active. We're going to select all of our members, meaning all of our beams and our columns within our model. Then we're going to find our Steel Design toolbar, which is usually located at the left-hand side of your screen towards the bottom. Here you're going to see we have two major commands. We have a Form Member command, which will be used to form a single physical member consisting of one or more analytical members that you manually select. Or we have the Auto Form Member command. This will be used to create multiple physical members in a single operation, which is what we'll do at this time. So we'll go ahead and click on the Auto Form Member command, and then Staad Pro has created our physical members. If we would like to see the physical members that have been created, we can go to our Page Control area, select your Geometry tab, followed by your Physical Member subtab. And we can see all the physical members have been created. If you would like to take a look at each individual one, you can review them. Now, it's important to note that although some of these members had been segmented due to modeling considerations in Staad Pro, and of course a physical member was created to form those members, it's also important to notice that the single members, like our column members, which were not segmented, are still creating a single physical member. And it is important to note that in Staad Pro, within the RC Designer, every member, every column, and every beam must be part of a physical member in order for it to be designed. We are now ready to perform our analysis and proceed to the RC Designer. To perform your analysis, we're going to go up to our menu bar, select Analyze, followed by Run Analysis. After the analysis is performed, we're going to stay in our modeling mode and then click Done. We are now ready to proceed to our RC Designer. We're going to select the Mode, menu bar item, and then select Concrete Design. Now, Staad Pro has two minds by which structural concrete elements can be designed. They can be designed in the modeling mode or within the RC Designer. The Reinforced Concrete Designer, or the RC Designer, is a design module that is integrated within Staad Pro. It uses the geometry and analysis results from Staad Pro, but it then allows for further definition of physical members and produces its designs accordingly.